myopic vision of what you're focused on. So you never know, you might need this information. Some lessons learned. So with that, I'll turn it over to you, Don.
Thank you, Jim. Okay, before we get started, let's find out a little bit about the audience. Who is representative of the power companies? Welcome. Any contractors? There they are. Regulatory authority? State or federal? Okay. Did I miss anybody? Attorneys? Researcher. Okay. All right. So we have a little more time here. That we only really have 3 presenters in this segment. So if as opposed to maybe wait until the end, if you see anything in here, I'm going to try to rip through what could be a 2-hour presentation or a 2-day workshop or a boot camp in 20 minutes. So just stop me. I'm probably gonna peso through some stuff pretty quickly. So again, this is straight talk. This is just distilling out the experience of Stantec in the CCR closure market. We do both engineering and groundwater remediation services. But the way we broke it out was the initial ash characterization. These are the processes, right, by which we move to closure. It could be closure in place, closure by removal. Now we're starting to intermingle beneficial use in with that and with closure. Initial ash characterization, dewatering, excavation, moisture conditioning, the transport piece, and then in placement, wherever that is. And then the last piece is a little bit of insight from what we're seeing in actual production numbers, the numbers that are coming off of these projects, and that we are seeing a little bit of a disparity between what you might see in the proposal stage versus realized production. A little bit about me, professional background. I grew up in the Ohio River Valley, where at some point in time in recent history, there were probably more coal-fired power plants than anywhere in the world. The legacy firm that is now part of Stantec, we were largely a geotechnical firm, and we got into this very, very early on, where way before it was cool. These images here are from 2006, where at a plant here in the Ohio River Valley, we were exploring whether we could build out a stack over a pond. Effectively not trying to move out in the green space, but actually stack out over sluice ash. So what came with that is a lot of geotechnical, kind of higher level geotechnical questions. The graphic there, the one with the yellow background, is pore pressure measurements. Pretty well accepted today that when you load up saturated ash, you get tremendous pore pressure spikes, which is not good, but it does dissipate relatively quickly. The graphic on the right is where we're just monitoring as we built. I think this one, we could just call it a test pad. As we built out test pads on sluice ash, the deformation, if you will, through an inclinometer. So from that background, this really took off seriously when the Kingston failure occurred, and we were the engineer of record for the Kingston Recovery Project. So the compliance progression, where are we today? By some accounts, don't hold me to this, but by some accounts, we've now spent $15 billion moving from, in CCR compliance, mostly driven by the CCR rule. I'd speculate that we're probably halfway. We're halfway there. Well, at least we were halfway there. Now we have the legacy rule. Maybe, it could come Q2 2024, and we start over. We go back, dig out do all the compliance demonstrations for, I don't know what you guys are seeing, but I've heard accounts of over 1,200 legacy units are now coming down the pipe. Business is good. So I'm going to try to focus on those elements that I laid out, the innovation that we're seeing also in construction, in the engineering process, and in the project management and controls. So you might want to help me with any of those because we're trying to collect them all, and they get away from us pretty quick. Ash characterizations, the very first piece. Yeah, you want to try to get the water off the pond. And then what you're left with is something that looks a little bit like a lunar landscape. The objective here is to begin to move from a lot of unknowns down to, move it through a funnel where you get knowns. So it's develop your design parameters that feeds into your closure design, a sequence, if you will, start to work out how you can progress a facility from this to closure, whether it's closure in place, closure by removal, which hinges on first step is a dewatering plan. It's rocket science, dewatering, but we pretty much have a grasp around it now, and there's not much in the way of innovation, but you have a couple paths, and we'll get into that. And then handling it in placement, again, it's just take all that into consideration in that ash characterization piece. How does it feed into those ultimate, basically, deliverables, if you will? Some of the core considerations is the operational history. We try to leverage everything we can out of that. What coal what was your fuel source? What emission controls did you have in place? How you operated the pond if you were sluicing? How often you moved your sluice pipe? If you never move your sluice pipe, you will see an accumulation of this super fine fly ash away, the furthest distance in the impoundment from the sluice pipe. That sometimes is a little problematic. That material, first glance, it all looks the same, but that's somewhat problematic material sometimes. Let's see, solutions. Get your design criteria. Like this, at this stage, you want to start whittling this out where all the stakeholders understand what your design criteria are. We lean heavily on a lot of geospatial modeling. Vein shear and CPT have come to the top because conventionally we would use standard penetration tests. We get a lot of zeros out of standard penetration tests. A below count of 0, that's what you got, right? We're talking about materials that are extremely, in terms of consistency, very soft. So hand vein shears for the near surface ash and CPTs at depth. It's pretty simple. This is where you want to move, to get the data that you can do something with, you can leverage moving forward. Yeah. Ash characterization, lessons learned. Again, the ops history, you want to leverage that. You want to focus your investigation at this stage on the things that matter. Maybe some of those things that where you we weren't able to assign that design criteria because you had gaps, data gaps. One thing that we've noticed is if you can identify transmissive zones where there might be bottom ash that is laminar, interbedded with your ash, that's transmissive horizontally, which will significantly affect your dewatering. The substrate and the seasonal high groundwater levels. This graphic here is where we have, we'll just call it a heat map, where we effectively just proof rolled a site that you could get on with a machine. We used, it was an articulated dump truck, because they basically float. It's not like some of our other pieces of heavy equipment. And we just did a subjective characterization of how the substrate responded to that equipment. The heat map, the red areas are the areas that are super problematic. But when you pass this on to a contractor, he begins to help. It can help him visualize how it can move a facility from where we are today to closure. Pretty simple, but it's very informative. Dewatering. The core objective is just move it from predominantly, these are water management projects. They don't look like water management projects, but that's really the focus. You want to move that into just conventional construction methodology, because that's really all we have. There's the only, I guess, maybe not the only, but in terms of specialized equipment that the construction industry has brought are amphibious excavators. Everything else looks just like heavy equipment on every other construction project. So you have to transition into conventional methodology. let's see, let's fast forward. On dewatering, definitely look at simplified gravity dewatering. You might call it passive, but gravity dewatering and active systems. It all depends on your constraints on time, but we're seeing a lot of success with, if you have time, begin to establish positive drainage and let gravity take its course. Lessons learned. Let's skip to this on this rebound concept. For closure in place, this graphic represents another heat map, if you will, where orange and red are where the seasonal high is very close to our proposed subgrade. So here we're balancing all the material on site, bringing ash from the perimeter to the center with, I guess you could call it a strange herringbone pattern, but in effect, balance on site, right? We're not importing anything except the actual cap. But when you do that, these areas in red are where we currently have groundwater at a relatively high level. And for a contractor, that's where things get problematic. So you just want to make sure that the focus on dewatering is addressing your ultimate grading plan. One other good point is try to do a pilot on whatever your dewatering methodology is. Something in the field that is proof of concept that dewatering will stay ahead of what your needs are in terms of dewatering with time. They're relatively simple. It's pretty quick, right, to get a feel for is what we're proposing going to keep us ahead of the dewatering game. Excavation. Core objective here really is that your production rates align with the schedule. The owner might establish a schedule. Maybe there's some other influence from other stakeholders, but there is ultimately a compliance schedule on closure. The contractors, typically, they want to match up their fleet to the allowable bearing capacity that you maintain during construction. In effect, we've got to keep the shiny side up, right, and keep this equipment upright. Today's methodology is predominantly, most of the materials move with hydraulic excavators. And I'll get into this production piece in a little bit, but what you have to do is account for seasonal variability. Certain parts of the country, you can just roll. But in other parts of the country, seasonally, your production, basically, I think on some facilities now, we effectively just call it like during the winter. There's a point where maybe you just need to stop burning diesel and just wait till the weather comes back to you for conditions that are more favorable. Lessons learned. We've tried them all. Wet dredging, yeah. No, not really. It's, you're not getting ahead of the water game. We did it at Kingston, but it was what we call time critical. We didn't have a choice. I've seen some vacuum, kind of these piston pumps. It just feels like it's a toothbrush, right? You're really low production rates where if for a specific application, maybe. But, I think one of the key elements here is that you have to continue the dewatering process. It's not just, you don't typically just get dewatering done and then you're just in the conventional construction method. Most of the time, you're progressively bringing the water table down as you're excavating. A new one that we wanted to share was what we call pond bottoms. Despite what data you might have for pre-development, like what you consider, okay, this is where we'll be done. We'll be at the bottom of the pond. It's either inaccuracies there or just the fact that what if your substrate's gray just like the ash is? So you want to account for that where, just a foot is 1,500 cubic yards per acre of over excavation. So you want to maybe work that into your design criteria on how clean is clean, or the fact that how are we going to confirm we're at the bottom of the pond. Moisture conditioning. Here the objective is to move it from looking like this to, something that you can handle as a solid. Lessons learned, I guess I referenced it earlier, that the evaporation rate that you're going to see is significantly affected by the prevailing weather. I can remember one afternoon at Kingston, I tried to get on like Googling weather science and try to figure out if there was an equation for this, but I never actually found it. But, temperature, humidity, and wind all affect your actual evaporation rate. And, if it's 40 degrees, it can look great out there, but we're not moving the moisture needle very much.
Real important is you watch your solar. A lot of equipment been lost.
Yep. Dry stockpiling is emerging as maybe that is an innovation. If you can, when the weather is good, if you overshoot that target moisture content a little bit, get it drier than target, that stockpile might be a source to get you through periods of inclement weather where you blend that material. It's not exactly rocket science, but I think we have seen applications of it where it does keeps production going. Lime conditioning, I think it is effective, but you always want to check back with your environmental group because a little pivot in pH can really get your chemistry out of whack on the groundwater side. I don't know if we have any geochemists here. They could explain that probably. Transport. Objective, got to move from point A to point B. Today our core options are rail, which we did at Kingston. Typically it's driven by, you're trying to move it a long distance. Conveyors, which conveyors are now coming back into the conversation when we're looking at pivoting from what might have just close it to, what about this beneficial use thing? Ash is a resource now. We're kind of changing our view of that. And conveyors provide some really interesting options as it relates to potential either short-term or long-term harvesting of the ash for beneficial use. Trucks, yep, we use trucks quite a bit. It kind of moves into that conversation about optimizing your fleet as far as keeping your production rates up. Transport lessons learned, ash is still likely to liquefy en route when it's at this, we'll just call it paint filter. Paint filter is pretty accepted in the industry, but it does not work very well for ash in that when you vibrate ash at paint filter moisture, it basically will go back to a liquid state. We saw it in rail cars, we've seen it in trucks. So your target moisture's probably, and again, in the interim, you might need to move it at that moisture content, but if you're moving it a long distance, you need to be cautious there. Conventional pans, what's the other word for pan? Scrapers?
Yeah.
I've seen people try it, but I think it's the ground pressure that gets them. It's not, we haven't seen it prevail as far as a transport method. Off-site routing has just all kinds of considerations. Anytime you're stepping outside, we'll call it the reservation. You got a lot to consider there. And for the number of units, they need to match your excavation fleet. There's a direct correlation between excavators and your transport units. In placement, of course, the objective is to whatever your regulatory permit says. Is it closure by removal? Is it closure in place? But it's basically where does it go? These are basically the performance criteria. What I would throw out, it's not very popular. I get a lot of criticism for this, but are we at a point now where we could shift to a performance specification where you could just do a test pad and the contractor demonstrates his ability to place the material and meet your performance requirements, and he follows that protocol. If you have a change in ash, if he changes his equipment, you do another test pad. As opposed to the full-time quality control like we're building a dam. We're not building structural fill, so it's just a consideration. today it's basically predominantly full-time, inspection, full-time QC inspection. In-placement lessons learned, measurement payment, in-place volume, not truck counts. Truck counts. So you just have a guy at the gate and he's holding the clicker. And sometimes he might be distracted. So he just hits his clicker. I think it's happened. So we've gone to now where, and I know most of you may be doing it, we're using drones for our surveys of in-place volumes. The next one is the high moisture. It's pretty sensitive. If I go back, I don't know if this curve illustrates it, but it really doesn't. The curve doesn't. But the material is extremely sensitive to moisture, and you might be at a good point right after lunch, but if you bring in loads that again tilt too far past optimum, you can find yourself in a real situation because these are all these processes are going at the same time. And if this process shuts down, then what are you going to do with the material that's being transported where you can't keep your end placement going? All those cogs have to stay in motion. The flat decks, when we're placing it, we have seen significant infiltration, if you will, and then the extended recovery time. So some consideration that you're going to maintain positive drainage in your in-placement area is pretty critical. And then shrink and swell, this one, we have seen, let's see if I can get this in context. We have seen, I think what's getting us now is cases where sluice ash occupies a certain volume in placement when you're compacting it with that compactive effort, there's a delta there. And as much as anything, it gets back to measurement and payment. Think through that in terms of, have that sorted out with your contractors. Production. So all of the processes that I went through all come into this element of production rates. Moving ash, point A to point B. What in major projects, there's this baseline that's set based on an assumed fleet, and I'll expand on what a fleet is. And the ultimate capacity is limited by something in one of those processes that I went through. There, you reach these constriction points where, again, all these cogs have to keep turning. When you hit that constriction point, that's it. That is your maximum production for each site. So, basic fleet, 3 trucks and an excavator. Contractors like to use 2,500 cubic yards a day. I had 2 fleets. Well, I'll get 5,000 cubic yards a day. And here is where it gets a little odd. I call it site physics. If you had 4 fleets, you're probably not going to get 10,000 cubic yards a day. You're going to hit one of these constriction points. It's either in transport or it's in moisture conditioning, but every site has these physics, and typically, if your construction team has experience, you'll know what those are, and you can kind of proof that. You might do some preemptive things to remove some of those constrictions, but we see this being pretty problematic. If this is if your proposed rate was 10,000 cubic yards, that can be a problem. So here's some examples. Everything's been redacted to protect the innocent. Project K was in the Midwest. There was over 100 pieces of equipment, 20 fleets. The active project limits were over 300 acres. We weren't constricted on space. The duration was about 5 years. We did have I'd say moderately harsh winters. The peak production was 10,000 cubic yards a day, and the average is 4,000 cubic yards a day. Project A is also in the Midwest. Sorry, these are impoundments, so this is that, probably worst case. Project A was in the Midwest, smaller site, 20 acres. You were doing closure by removal to an off-site with a 20-mile haul. They did implement dry stockpiling, dry for the winter to keep the project going. They were stockpiling dry material. Peak production was 2,500 cubic yards per day, and the average was 2,000. On the dry ash landfill side, Project S is in the Midwest, 50 acres, 2 years, dry stack to on-site landfill. So a pretty short haul, no on-road trucks, but a mile haul. And they went with Cat 657 pans, basically massive mining equipment. Peak was 10,000 yards. There were some days where they got 10,000 yards, but the average was 7,000 yards. Project Y is in the south, and this is a very narrow site, a physically constricted site. Pretty quick, 2 months. Dry stack to dry stack, though, right on site, just moving it from basically hardly no moisture conditioning, just load and haul. 2,700 cubic yards a day, and average of 1,700. So you can see that scaling up, you'll hit a upper end very quickly. And that's it. 20 minutes.
A little longer, that's okay. Questions?
Done. Any questions from the audience? Questions? Mark?
What was the project B size?
I'll have to go back and refresh my memory. A, the fleet. I think it was at least 3.
Do you believe that early contractor involvement could help with a lot of the design to account for all those maybe small places and optimize the routes, or anything that has to do with that involving the contractor in the design phase versus putting a bid out?
If your contractor has considerable experience, I think there is value there. And if it's viewed as it's a true partnership, there's true collaboration there. Yeah.
Quick question, just on the local angle on Kingston. Was there a lot of ash removal done in the river, and what happened to the majority of the ash that was in the river?
There's no attorneys here.
Did not recall recording any.
All right, let's see. I'll go by recollection. Yes, that we had a time critical phase and a non-time critical phase. But at the point where we were moving ash from the river, we were wet dredging. We had excavators sitting on barges, literally dipping ash directly out of the river and just setting it in the barge. So those are the 2 primary methods of, we'll just call it wet dredging, removal. And at some point, there was a study done. There's some science behind it, but EPA said no moss, and the balance of all that ash was left. But we got most of it.
Okay. I know I did hear that some studies show that there was